Sri Gurubhyo Nama children, welcome to online training initiative Ekalaiva. Already we are discussing about the topic alcohol, phenol and ethers. In the last class, we have started to prepare alcohols. I have started with the preparation of alcohols. Only few methods of preparation we have seen. We are going to see the remaining methods today. In the last class, I told about the preparation of alcohols from various compounds. We have seen so many examples. Today, I am going to start about the preparation from esters, which is based on reduction. So, we can reduce certain compounds to prepare alcohol. Under reduction, in the last class, I told about the reduction of carboxylic acids, reduction of aldehydes, reduction of ketones. So, if it is aldehyde, I got the product as primary alcohol. If it is ketone, I got the product as secondary alcohol. If I use carboxylic acid, I got the product as alcohol. Today, we are going to see another important reaction under reduction from esters. So, we are going to reduce esters to prepare alcohol. Are you ready, children? Be ready with your notebook. So, we are going to talk about preparation of alcohols. Under that, we are going to talk about reduction of esters. So, what is reduction? Already I told you. Reduction is nothing but addition of hydrogen or removal of oxygen. What is reduction? Addition of hydrogen or removal of oxygen. Addition of hydrogen or removal of oxygen. Or removal of oxygen. Okay, we can call it as reduction. Either we need to add hydrogen or we need to remove oxygen. So, removal of oxygen or addition of hydrogen is reduction. From esters. So, esters are reduced. What are esters? Esters are sweet smelling substances. These are sweet smelling substances which are obtained from, these are sweet smelling substances which are obtained from alcohols, which are obtained from alcohols and carboxylic acids, which are obtained from alcohols and carboxylic acids, which are obtained from alcohols and carboxylic acids in the presence of mineral acid. In presence of mineral acid. So, what is the method we are going to discuss here to prepare alcohol? That is reduction of esters. First I told about reduction. What is reduction? Either addition of hydrogen or removal of oxygen is known as reduction. And what has to be reduced here? Esters. You should know esters. What are esters? Esters are sweet smelling substances, fruit smelling substances, pleasant smelling substances. So, esters are pleasant smelling substances which are obtained from carboxylic acid and alcohol. So, what are the two reactants we need to prepare esters? We need alcohol and carboxylic acid. Apart from that, I need acid catalyst. So, in the presence of a mineral acid, alcohol and carboxylic acid combine to give esters. So, first step we are going to prepare ester. Second step we are going to reduce esters to get alcohol. So, we are going to see the reaction now. So, what is the first step? Esterification. What is step 1? Step 1 is esterification. Esterification reaction. Formation of esters from alcohol and carboxylic acid. So, esterification step. So, what is esterification? Let us write the alcohol and carboxylic acid. I am writing ethanol, which is an alcohol. Ethanol reacts with ethanoic acid. Ethanol reacts with ethanoic acid CH3COOH. So ethanol reacts with ethanoic acid. Okay. What is the catalyst we are using here? In the presence of mineral acid as catalyst, in the presence of H plus as catalyst. So what is that we are going to give? OH from alcohol and hydrogen from acid will be removed as water. So what is the byproduct we are getting here? OH group from alcohol and hydrogen from acid is removed as water, which is a byproduct. So the byproduct is water here. What is the main product? Let us write the remaining species. CH3, CH2. So left hand side, what is the group remaining? CH3, CH2. What is the center? This is the ester group, is it not? So it will be in the center. COO, okay. What is remaining towards the other side? CH3. So what is the name of this compound? It is a ester. How do we name this compound? Ethyl acetate. Ethyl acetate. What is the ester we are getting here? Ethyl acetate. So first step is over. So what is first step? Formation of ester, that is esterification reaction, preparing esters from alcohol and carboxylic acid in the presence of mineral acid. Okay. What is the second step we are going to see? Reduction. So what is step 2? Reduction. Reduction of esters. Reduction of esters. Let me see what happens when esters are reduced. So write down. So I am writing the ester now. What is the ester I got in the previous step? Ethyl acetate, CH3, CH2, COO, CH3. So this is ethyl acetate. It undergoes reduction. I am adding hydrogen. I am adding 4 hydrogen in the presence of, what is that? Either I can use sodium borohydride. I am using sodium borohydride. So what is this actually? The name of this compound is sodium borohydride, which is a reducing agent. Sodium borohydride, which is a reducing agent. So which is a reducing agent. Okay. So I am adding hydrogen in the presence of sodium borohydride as a reducing agent. How many hydrogens I am adding? 4 hydrogen. Let me see now what is the reaction that takes place here. Listen here. Out of 4 hydrogen, listen here, we are going to add, I am going to split the compound like this. See this group. What is this group? Methyl plus oxy, methoxy. So this is methoxy group, alkoxy, methoxy, methoxy group. Okay. What is this group? Acetyl group. Acetyl group. So this is methoxy, this is acetyl group. Okay. So out of 4 hydrogen, 1 hydrogen is added to methoxy group. So what is that we are getting here? CH3OH. So already oxygen is there. Out of 4 hydrogen, 1 hydrogen is added to the methoxy group. So what is the alcohol I am getting here? Methanol. What is the alcohol I am getting here? Methanol. Okay. Come to the other side. How many hydrogen atoms are remaining? 3 more hydrogen atoms are remaining. Out of 4, 1 hydrogen is added to the methoxy group. I have converted into methanol. 3 more hydrogen atoms are remaining. So these 3 hydrogen atoms are brought inside. I have to add here. So what is the compound I am getting here? CH3. Okay. You write CH3 as it is. CH2 as it is. Okay. What about CO? Here I can add 2 hydrogen. You add 2 hydrogen here. So 2 hydrogen to carbon, 1 carbon and 1 more hydrogen to oxygen. So 2 hydrogen atoms you add to carbon and 1 hydrogen to oxygen. So what you will get? CH3, CH2, CH2OH. So already CH3 is there and CH2 is also there. 1 more carbon is also there. You add hydrogen. So what is the compound we are getting here? Propanol. We are getting a mixture of alcohols. we are getting propanol and methanol. There are 3 carbon, is it not? So this side when you see, there are 3 carbon. So we can get alcohol with 3 carbon. What is the name of the alcohol with 3 carbon? Propanol. What is the other side? I am getting methanol. I am getting a mixture of alcohols. So here I am getting 2 different alcohols. One alcohol has got 3 carbon atoms. The other alcohol has got only 1 carbon atom. I got a mixture of alcohols here. So this is reduction of, what is that, esters. So in reduction of esters, I followed 2 steps. What is the first step? Esterification. So I produced esters in the first step by reacting alcohol and carboxylic acid in the presence of mineral acid. So I got the ester in the first step. What is the second step? I have reduced the esters. So esters undergo reduction in the second step. What is the reducing agent I have used here? Sodium borohydride. How many hydrogen atoms I have added? 4 hydrogen atom. I have split the ester into 2 different groups. One side alkoxy, other side acetyl group. So hydrogen atoms are added to both the groups. One side to the alkoxy, that is methoxy, I have added hydrogen. I converted the methoxy group after hydrogen into methanol. Towards the other side, I got acetyl group. 3 more hydrogen atoms are remaining. I have added there. I have converted into propanol. So here I got a mixture of alcohol. I got 2 different alcohol. One is propanol, another one is methanol. So this is one method of preparing, what is that, alcohol. The next one we are going to talk about from Grignard reagent. From Grignard reagent. What is Grignard reagent? Organometallic compound. Organometallic compound. So what is organometallic compound? Organo means what? It will have organic group. Organic group which is indicated by R. So what is a Grignard reagent? Which is an organometallic compound. So what is a organo means what? Organic group which is indicated by R. This R can be any bulky group like methyl group. It can be ethyl group. It can be, what is that, phenyl group. So R can be anything. It can be methyl, ethyl or phenyl group. So R is compulsory in Grignard reagent, which is an organic group. Methyl, ethyl or it can be a phenyl group. Okay. And what is that? How can we indicate what is a metal? Usually it will have a metal also. Here I am using a metal magnesium. What is this actually? Magnesium. Mg, which is a symbol for magnesium. Okay. Apart from that, what is that? It will have a halogen also. It will have a halogen. Halogens are indicated by X. So in short, how can we represent the Grignard reagent? It is RMgX. What is RMgX? It is nothing but the symbol which is used to indicate Grignard reagent. What is Grignard reagent? Organometallic compound. So it will have an organic part. What is an organic part? Which is represented by R. It can be methyl ethyl, it can be a phenyl group, whatever it is. What is the other one? In the center you can see a metal. Here I am taking magnesium. So apart from R, it will have a metal also. Here I have taken magnesium. Towards the right hand side, I can have a halogen. So halogens are indicated by X. It can be chlorine, bromine or iodine. So out of these 3, it can have any one of the atoms. So X is indicated as halogen, which can be a chlorine, bromine or iodine. So what is the symbol of Grignard reagent? So Grignard reagent is represented as RMgX. Grignard reagent can be represented as RMgX. Okay, let me see now. This is a carbonyl compound. Carbonyl group. What is the name of this group? carbonyl group. Carbon and oxygen will be bonded by a double bond. In between carbon and oxygen there is a double bond. So we can call this group as carbonyl group. Especially if we can say some compounds that have carbonyl group. Particularly we can talk about aldehydes, ketones, carboxylic acids, etc. So these compounds they will have what is that? Carbonyl group. Let me see how Grignard reagent reacts with carbonyl group. What is the speciality of this Grignard reagent? So I am indicating the Grignard reagent as RMgX. So what is the Grignard reagent here? I have represented here as RMgX. So this is Grignard reagent. Okay. Let me see the reaction. What is the nature of this Grignard reagent? Polar nature. Polarity. Ability to develop partial positive and negative charges over the respective atoms. Development of partial positive and negative charges. Ability of developing partial positive and negative charges over the respective atom. That is called polar nature. So here when you talk about this Grignard reagent, the bond between R and Mg, the bond between R and Mg is shifted towards R. The bond between R and Mg is shifted towards R. As a result, what is happening? R will develop a partial negative charge. This bond between R and Mg is shifted towards R. Already I told about R, which can be a bulky group, which can be a methyl, ethyl or phenyl group. So the bond between R and magnesium is shifted towards R. As a result, as the electron pair is moving towards R, so this R will develop a partial negative charge. As a result, what will happen to this group? It is losing electron pair. So Mgx is losing the electron pair. On the other hand, R is gaining the electron pair. Whenever any atom that gains the electron pair, it will have a partial negative charge. So partially the electron pair is gained. So R is gaining the electron pair partially. So whenever any atom is gaining the electron pair or pulling the electron pair, it will have a partial negative charge. As the bond between R and magnesium is pulled towards R, so R is gaining a partial negative charge. On the other hand, Mgx is losing the electron pair partially. The other part of Grignard reagent, that is Mgx, it is partially losing the electron pair, so it will have a partial positive charge. Whenever an atom is losing the electron pair partially, so in such a case it will have a partial positive charge. When an atom, what is that, gains the electron pair partially, it will have a partial negative charge. This is polarity. That is development of partial positive and negative charges over the respective atoms due to the electronegativity difference. So let us see the reaction now. If it is formaldehyde, which is methanol, or it can be, we can call it is an aldehyde, methanol, formaldehyde or methanol, which is an aldehyde group. So it reacts with Grignard reagent, CH3MgI. So what is that we are going to do? This bond is shifted towards oxygen. As a result, what will happen? Carbon will have a partial positive, it will have a positive charge. Deficiency. Carbon will be electron deficient. So what is happening here? This methyl group will go and attack the carbon because it will have a negative charge. It's not delta negative. So it will be delta positive. As oxygen is, as this bond is shifted here, what will happen? Oxygen will have a negative charge. So it will go and attack the carbon. So attack the oxygen. Let me see the reaction now. So H, C, double bond will become single bond, oxygen, okay. So what is happening there? The bond between, what is that? Oxygen, carbon and oxygen is pulled over oxygen. So oxygen becoming a negative. So this Mgi, which is positive, will go and attack the oxygen. See the other side there is hydrogen, and this partial negative atom will go and attack the carbon because carbon is electron deficient. Carbon is positive here. So methyl group is attached to the carbon, it will form an adduct. What is the compound we are getting here? Adduct, unstable compound, adduct. So what is the next step? It undergoes hydrolysis. So it undergoes hydrolysis. So rearrange the compounds now. CH3, okay, write down. CH2, okay, write down. What is remaining? Oxygen from here and hydrogen from here will combine as OH. So oxygen from here and hydrogen from water will combine as OH. What is remaining? What is the name of this compound? You are getting ethanol. Okay. What is remaining? Mg. One side. Towards the other side, I am getting I. Towards the other side, I am getting OH. Again, I am getting an unstable compound as a byproduct. So this is the reaction. So when it is methanol, I told about the mechanism of aldehyde or ketone with Grignard reagent. I told the polar nature of Grignard reagent. I told what is negative and positive in Grignard reagent. And when the bond between carbon and oxygen is shifted towards oxygen in formaldehyde, oxygen is having a negative charge. Carbon will be positive. So in Grignard reagent, bulky group CH3 group is negative. So it will go and attack the positive carbon. Bond formation is taking place. Again towards the other side, oxygen is negative here. So it will attack the Mgi from Grignard reagent, which is positive. So here a compound is formed as an intermediate. We can call it as adduct, which is an unstable compound. What is the next step? Hydrolysis. We are adding water. So after adding water, what is that? We are rearranging the compounds. So what is that we are getting? After rearranging the atoms, I got the main product as ethanol with the liberation of Mgi one side and OH another side. Again unstable compound. This is one method of preparing alcohol. I have given only one method under Grignard reagent. So in the next video, we are going to see the other two methods. Thank you children. If you like this video, you please click the subscribe button. You will get the latest updates of our online lessons.